Hello everyone! Now that we've completed the asset importing and lighting sections, we are ready to explore the NetworkMaterialCreate and MaterialAssign nodes, which are crucial components for texturing and shading in Katana. Our goal is still to dress our buddy robot Emis in various outfits. So let's get started! First, let's introduce the NetworkMaterialCreate node, or NMC for short. The NetworkMaterialCreate node is the starting point for texturing any models. It is designed to house your material network, featuring a left-to-right workflow, which enables you to work more efficiently, making building and editing materials as quick and simple as possible. It holds the function of one or more network material nodes, as well as the Network Material Interface Controls node. Now, let's proceed and add the NMC to our recipe. Typically, NMCs have their own branch, and we use a merge node to connect them to the rest of the tree. Much like what we did when setting up our camera. We'll assign a generic name to our node, since we'll be creating 4 shading groups within it. By default, Katana automatically places the material below root/materials in the scene graph, so there's no need to be concerned about its location, unless you would like a specific scene graph location, which differs from the default one. Is your material lost? Simply give it a location. We can also assign a namespace for our material and drag-drop the network material we created just below the namespace. We can add as many network material as we would like under that namespace. Inside the NMC, we'll start by setting our rendering engine to Arnold by pressing Shift-Tab. In this case, our robot has 4 different shader variations, and we can conveniently create them all within the same NMC. We'll add an Arnold shading node, assign it a name, set its node type to image, and employ an expression to reference all our UDIMs for the diffuse shader. This process repeats for roughness, metalness, emission, bump map, and transmission nodes. Each node gets a distinctive name, and we'll update the expression to point to the correct texture file. Additionally, we'll include a clamp node for our transmission image as a utility shader, so we will make sure that we keep our values between 0 and 1. We could also find our texture file node directly by typing image in the tab menu. Now that we've imported all our texture files, we can connect them to our shaders. The first one we will be adding is a standard surface shader, renamed White Robot Surface. To facilitate this connection, press Alt-2 to display all the available ports for linking our texture files. We will adjust our shader a little further when we test render our materials. We can add a name prefix and a page prefix on the public interface of the shader too. Let's take a closer look at that. As we would like to specify that these parameters we will be promoting belong to the standard surface, we will add standard surface underscore to the name prefix and a page prefix of the public interface. Click on the wrench icon and expose those internal node parameters on the NetworkMaterialCreate's Parameters tab for convenient access. The wrench icon is now yellow, indicating that the parameter has been added to the material interface. We can now access those parameters without having to jump in and out of the node. These parameters will also be exposed under the attributes of the asset once the material is assigned, which we will see shortly. The second shader we will be adding will be our glass layer. We will proceed by creating a standard surface shader and adjusting the settings to create a glass material. I will bring the diffuse base weight to 0. Add a bit of specular roughness as my glass material won't be perfectly clear, and I will plug my transmission mask to the weight transmission. If no transmission texture files was created, the transmission weight should be set at 1. Once this step is completed, I will layer my shaders using a layer shader node, where I will adjust the mix until I am satisfied with the result. For now, I will set it to 0.3, and I can come back to it when our materials are assigned to our robot, and I will be test rendering it. I am simply setting everything into place for now. As we are organized people, but also artists who love colorful and shiny things, let's create backdrops and assign corresponding names. We can also color code our nodes based on their respective shaders. We can group all our work into a shading group node. Select all the nodes, press G, and we are set. We can expose some group parameters by dragging the inputs we want to expose to the far left of the group node under Input. In this case, we'll focus on promoting the file's names at the group level. To keep all those promoted parameters organized, we can also take advantage of the public interface provided on the shading group itself. In this case, we will rename the name prefix and the page prefix to white robot underscore, as the first shader variation will be a white metallic outfit for MS. We have 4 different shader variations for our character. So we'll replicate the work we've just completed for one shader by copying and pasting it 3 more times. Some shaders may not contain all the same elements, so we can enter our shading group and remove unnecessary files. While these setups are straightforward, we can build more complex networks if required. We can then change the name prefix on the group itself, so we keep all our elements easy to spot and to modify. We can see on the network material interface that all our promoted parameters are correctly named with the prefixes we previously assigned to them. If we wanted to have even greater control over some parameters, we could go under Visibility and Locking and manage the visibility or lock of some parameters or pages with operations or conditions that we could set according to our needs. And we could also adjust the ordering of our parameters under Source and Order by dragging them above or below others as desired. Now, it's time to assign the shaders we've created to our asset. To do so, we need to create some MaterialAssign nodes. We will first drag the asset path into the cell statement. If we were assigning our shaders according to our previously built collections here, we could simply drag the path of the collections into the collection field to assign our shaders to different components of our model. To avoid repeating the same task again and again, we will use an expression in the MaterialAssign field. I will drag the path of the material and add node name.lower, so my material name is in lowercase. This way, I can simply copy-paste this node 3 times and change the name of the node instead of going back and forth to edit the material every time. To have easier control over those variations, we will set our graph state variables with a variable switch node. We will connect each MaterialAssign node to our variable switch inputs. We will set our variables using the Project Settings tab, which affects all node graph branches in the entire project and are, therefore, referred to as global. To define our new global graph state variable, we will open the Project Settings tab and locate the variable's group parameters, where we will click the Graph State Variables menu and choose Add Variable. By clicking the branch menu of the newly created variable and choosing Rename, we will be able to enter the same variable name as we used in our variable switch name, which was Material, and click OK. You can then enter each value or patterns previously set in the variable switch for the variable in the drop-down widget. And there, you have it! All our shader variations are now effortlessly accessible at the top of our UI. We can see our lighting variations and our shading variations. So much control! After clicking on the implicit resolvers and then attributes, we can now observe that under Materials, the parameters we exposed are displayed. Attributes are what drive Katana, so if you ever have any doubts, it's a valuable reference point to verify whether your work is correctly constructed. The renderer will resolve all this information at render time. We can now test render our shading network and see how each part of the shading network contributes to the final look of our robot. Under the white material, we can solo view each part of the shading network. With the live render running, press the 1 to 9 keyboard shortcuts to preview different points of your network, and the render updates to display the material output from that point. Then it is easy to tweak and modify your parameters to refine the look of your model the way you'd like. When the modifications are completed, we can turn off the material soloing mode by clicking the soloing icon or by pressing 0 to return to the network material view. Now that we have our asset loaded, textured, and lit within our scene, we can begin testing the work we have done in our template so far. Let's initiate a preview render with the Rusty shader to look at how our renders react. The status line is purple, which is a positive sign. It means that our render isn't failing or has not failed yet. You can always refer back to the render log to track the progress. If you prefer real-time editing without the need to start and trigger a preview render again, you can also use live rendering as we used it for soloing our materials. Congratulations! You've completed the most important part of your work. Emis is now a live character, fully shaded and ready to undergo his career. To wrap up this phase, let's add another dot node and call it Out. To summarize this third video, we created an NMC node where we built 4 variations of shaders for Emis. We promoted key parameters at the group level and on the material interface. We merged these materials into the main tree and assigned them to our model. We added a variable switch for quickly transitioning between the different shader variations, and we closed this section with the out dot. Excellent work!